The final examples that I want to look at when it comes to simplifying radicals is ones where we might have to rationalize the denominator. So let's walk through these two examples. The process is exactly the same. In order to make my life a little bit easier, I might go through and try to simplify this fraction before I start simplifying my radical. So if I look at this, 20 over 9 doesn't reduce, but if I look at the x bases, I can simplify those. X cubed divided by x is x squared. I don't have anything to go with that y. And in the denominator, the 9 didn't change, and I don't have anything to go with that z. So this is what we have. And again, because there's not an index written there, this is a square root. That means our index is 2. So I would go ahead and break this into two radicals, and we're going to simplify each one separately. So this is the square root of 20x squared y squared over the square root of 9z cubed. First thing we're going to do is simplify both the numerator and the denominator. So let's start in the top. Biggest perfect square that goes into 20 is 4. So the square root of 4 is 2, and that leaves us with 5. 4 times 5 is 20. Then again, remember that the index that we're imagining is here is a 2, even though it's not written. So how many times, when we look at the x's, how many times does 2 go into 2? It goes in once with none left over. Same thing with the y's, once with none left over. So we're left with 2xy times the square root of 5 in the numerator. Now in the denominator, we want to see if we can simplify the square root of 9. Now 9 is a perfect square. It's on your list. So a 3 would come out. Then we look at the z's. 2 would go into 3 once with 1 left over. Now, when we are rationalizing, we only have to worry about the radical. That 3z is totally fine. We can leave that there because it doesn't have a radical on it. In order to make this build up the way that we've talked about, remember this is a square root. So since this is a z to the first, I need one more to get that to be a z squared. So I'm going to multiply numerator and denominator by the square root of z. That's all I have to worry about. And so these radicals match, so we can multiply under. The 2xy is outside, so it's not going to be bothered. We're not going to do anything to that. But then I have the square root of 5z over 3z times, here's where we got to be a little bit careful. The square root of z times the square root of z gives us z, but then you'll notice that I have terms I can multiply together here. So our final answer will be 2xy times the square root of 5z all over 3z squared. No more radicals in the denominator, so that is completely rationalized. Okay, number 6, you can do more than one way. So we could go ahead and simplify first. This would be your first option. If I did that, I would have negative 3 over 5 goes into 6 once with 1 left over. So now to get that up to a 5th power, we would need, this is the first, so I need to add 4 to that exponent. So I'd multiply times the 5th root of x to the 4th over the 5th root of x to the 4th. In my numerator, that's going to give me negative 3 times the 5th root of x to the 4th over x times these two together give me x. And so our final answer is the 5th root of x to the 4th, negative 3 times the 5th root of x to the 4th over x squared. So that's one way that you could have done this problem, and that totally works. If you just want to always know, simplify first, do the rest later, that's great. Now, The other option, sort of a different way that you could have looked at this, and again, it's not more right, it's just different, it's a matter of preference, is you could look at this and say that I want to multiply instead by the 5th root of x to the 4th. So think about what that would accomplish if we did that. See if you can figure out why I'm doing that. 6 plus 4 would give me 10. So I get negative 3 times the 5th root of x to the 4th over the 5th root of x to the 10th. Now when we simplify, I have picked an exponent down here. The reason why I built up to 10 is because I know that 5 goes into 10 evenly. So the top is simplified, negative 3 times the 5th root of x to the 4th. But then what's going to happen down here is 5 goes into 10 twice with none left over. So there we have our answer right there. Again, one's not better than the other. It's just two different ways to look at the same problem. Make sure that you always rationalize. If it's not rationalized, it's not done and it's not all the way right.